Hi, I'm Tom Stephenson, and welcome to our lecture today. I'm going to do things a little bit different than normal. I thought I'd get back to the old whiteboard, and that might be a little bit helpful that way. So, I've already done a recorded lecture on stairs, which is our previous lecture to this one. And I kind of went through it, but I thought, it's not bad if you can actually just walk through it step by step as opposed to having the slides already done. And I usually do it in the classroom this way, so I usually have something I do live. And then if I make mistakes doing it too, you can see the mistakes along the way, and then we correct it and we kind of work our way through. Because anytime you do stuff live, you are much more bound to make mistakes. The only difference is I don't have you to point them out to me, which is always nice. And I mean simple sort of math mistakes. Sometimes when you're doing things on the fly, you enter something wrong into your calculator. So what we're going to do is we're going to figure out a unit rise, unit run for a stairs, how that works, and a stairwell opening and how that works. So we're going to run through those different scenarios. We're going to assume an unlimited run for this particular stairs, and I'll sort of give you the parameters of what we're discussing. And so, we're saying that we actually have an unlimited run in this particular example. The truth is you generally have a limit on the run, but you work within that. But we'll talk about that as we go along. We just want to have some parameters of how this can get calculated. So we would have a total rise from our finished floor, which would be this point right here, our finished floor, to finished floor. And so by finished, I really mean finished. I know when we talked about construction drawings, it says finished floor to finished floor, and it just talks about the subfloor. In this particular case, we're actually looking at the finished floor. Hardwood, ceramic tile, those types of things. In many cases, it doesn't really matter because if you're using 3/4 inch hardwood on this floor and 3/4 inch hardwood on that floor, it doesn't make a significant difference, right? Because they're the same, so the height doesn't change. But if you had, say, a dry packed concrete going on top of this subfloor with a thick granite, and then you just had hardwood flooring up here, well, this could be like 2 inches thick, and this is only 3/4 of an inch thick. It's going to change the finished floor to finished floor height. So that's what I mean by finished floor to finished floor. All right, so let's take an amount. So let's say 8 foot 10 inches. So let's say we have 8 foot 10 inches from the top of this floor to the top of that floor, right? And what we want to do is we want to calculate using the ideal rise and run. In the previous lecture, I mentioned that the ideal rise and run, if we're talking imperial, we'll say is 7 and 10. All right, so 7-inch rise and 7-inch run, unit run. So these are unit runs. Might have trouble fitting everything on this smaller whiteboard. I'm used to like a big whiteboard. Anyway, so we got 7 inches for the unit rise and 10 inches for the unit run. So just to recap, this is our unit rise. So that is, I'll just put U rise there. So that's our unit rise from top of tread to top of tread. All right, our unit run actually goes from face of riser to face of riser. So our unit run is actually UR run from face of riser to face of riser there. That's our unit run. Okay, so we've got those elements, and so I'm saying standard unit of rise is 7, standard unit of run is 10 inches. It never works out to 7 inches because this would have to be a perfect multiple of 7 inches. And so we want to make sure, and the building code requires us to have all of these equal. So the unit rises all have to be equal. There's some minor tolerance acceptance, but like let's just assume we're going to make them exactly equal, and that's the way we should. So I would take that 8 foot 10 and I would make that into inches. That's the first thing I would do. So we got 8 times 12 is 96 plus 10 is 106 inches. So we're going to go 106 and we're going to divide by 7. Okay? So we're going to take that 8 foot 10, that's 96, and we're going to add that plus 10, and then we're going to divide by 7. As I said, I like to do this live. So we're going to go 106 divided by 7, and that's going to give us 15.14286. So 15.143, I'll call it. 15.143. So that means we have 15.143 risers. And so if I round that off mathematically, that means we're going to have 15 risers, because we don't want to have 0.143 of a riser. Everybody's going to trip on that. And just getting back to why we have 7 and 10. 7 and 10, and again, you can research things, and there's different sort of formulas out there. So, don't anybody freak out that it's, I've seen this or this or this. But generally, 7 and 10 is widely accepted as a very comfortable step. If you're stepping up, and if you step up really steep, you tend to not want to step out too far. Conversely, if you're not stepping up so much, then it's easier to be more like a walk. All right, it's not exactly a walk, but it's more close to a walk. So the way that we come up with this combination of 7 and 10 to get a comfortable rise run, 7 and 10, 7 plus 10 equals 17. So these two should add up to 17. So if one of them happens to be, as an example, 6, then the other should be 11. Because if I don't have to step up as much, 6 instead of 7, then it's easier to have a little bit wider tread, so it's more of a walk kind of thing. It's not walk, but it's less steep. So at our college, actually, we have a stairs in C building, which was built in the 1970s, has a very low unit rise. Like, I'm going to say it's probably around 5 inches, the unit rise on those steps. But it also has a very long unit run. So it has a very long unit run. So it's almost like a walk. And that's probably, if you looked at it, I bet you more than likely the unit run is like 12 inches and the unit rise is probably 5. Add up to 17 as an example. So that is a very comfortable step. And trust me, you notice a stairs, people that aren't as in good a shape, they notice a stairs that doesn't have a comfortable step to it. So if you're going by the building code with a very sort of high unit rise and basically a long unit run, it's not as comfortable. It feels a little bit more steep but not comfortable, like to go up it, right? So ideally, we try to keep close as possible to the 7 when we're working this out. So we take this, and this would be rounded to 15. So we'll call this 15 risers. So we're going to have 15 risers for sure when we're done. Then we're going to take we're going to go back and we're going to divide 106 by 15. So we're going to divide 106 by 15. So that should give us what we're after, 106 divided by 15. Okay, so that equals 7.06. 7.06667 if I want to be exact. All right, so I think I know where this one is going. So 7.00067, then what's going to happen is, if you want to find out, because who deals with decimals when you're using a measuring tape? No carpenter deals with decimals when they're dealing with a measuring tape. Deal with fractions of an inch, right? For those of you that you're not used to that in construction yet, you'll see that's how that tends to work. So 7.0067, I'm going to take that 0.06667 and I'm going to multiply it by 16 because I want to know what it is to the nearest 16th of an inch. How much is that to the nearest 16th of an inch? So I go 0.06667 times 16. I already know what this is going at, but anyways, I'm going through the motions. It comes to 1.006 something, 6672. Seems like there's too much glare for you to see it anyways. All right, so that's a 16th of an inch. You round it off, right? So that equals 1.0667. This, when you multiply by 16, it tells you how many 16ths of an inch, all right? So when we multiply that fraction of an inch, if I wanted to find out to the nearest eighth of an inch, I'd multiply by 8. If I wanted to find to the nearest quarter, I multiply by 4. If I was a cabinet maker and I wanted to find out to the nearest 32nd, I multiply by 32 and it'll tell me how many. Those of you good at fractions that work with it for a little while, you get to know 0.125, that's an eighth of an inch, 0.25, that's a quarter of an inch, and so on and so forth. So you can eye it pretty much. You don't even have to really go through that, but that would be 1/16. So I've got, with that, I've just figured out that I have 15 risers at 7 1/16 of an inch. So 15 risers at 7 1/16 of an inch. So that means there would be 15 of these if this was drawn to scale going up my stairs, right? And with stairs, I know that if I have 15 risers, I'm always going to have one less tread. There's always going to be one less tread. So that means I'm going to have 14 treads or unit runs, because I got to be careful how I say that. I talked about that in the previous video. Just to recap, a tread, if we're talking about a stairs, a tread, right? A tread is the unit run, face of riser to face of riser, plus the nosing. And the nosing can't be more than 25 millimeters or 1 inch. Can't be more than 1 inch, the nosing. So, but it's easy to say that's the horizontal piece, the tread. But when I'm saying that, that's what I mean. All right, so the tread. So I have 14 treads. I always have one less. So I'm going to say 14, but I'm not going to say tread because I don't want to confuse people. I'm going to say unit runs. All right, at. Okay, and then I'm going to say 9 15 sixteenths. 9 15 sixteenths of an inch. So if I have 15 risers at 7 1/16, then I have 14 unit runs at 9 15 sixteenths. Right? So I got 14 at 9 15 sixteenths. So that tells me the relationship there. So that means these would be 9 15 sixteenths, and these would be 7 1/16. So the vertical members are 7 1/16. Horizontal would be your 9 15 sixteenths. So it's like I've almost got this here, right? So I've almost got that little triangle there. So that's my rise, that's my run. Unit run. Okay, so I've got those two figured out. And if some of you are scratching, where do you get 9 15 sixteenths? Well, I took 17. Remember, that's the ideal number. So I took the ideal number that these should add up to. So I took 7 1/16, and I said 17 minus 7 1/16 equals 9 15 sixteenths. That's where that came from. That's where that came from. That's using that ideal rise run formula. And it's in your textbook, so you can see it in your textbook. And go through that, or go through the previous lecture, the one to this. I think it's, what is it, 9B, I think. Go through that one, and you'll see it. Okay, so we have this to give us that rise-run relationship. So we got that figured out. Now, I'd like to know how far it is going to end up from the face of my stairs to here. because I said I've got an unlimited run. That means I'm really not worried about too many things. But in the real world, we're generally worried about some things. You know, sometimes there's a wall here, and so you got to have enough room for a landing in that spot. So you want to know, where is this going to come out? So all I have to do to figure out this length is multiply 14 times 9 and 15/16. All right, so all I got to do is multiply 14 times 9 and 15/16. You know, you could do this different ways. You could look at this and say that's 140 inches, and then you could say there's 14 of these, so that's 14/16, and then you could say, all right, so that's 139 and an eighth inches. I'm not sure I trust myself doing it so quickly like that, but that's one way of looking at it. But if that's not, you know, your thing to look at it and try and figure it out that way, probably a good way of doing it, you could convert that. Those of you that are more used to decimals, you might prefer to go 15 divided by 16 equals 0.9375. So I could say plus 9 equals 9.9375. Then I could say times 14 equals 139.125. And I know 0.125 is an eighth of an inch, so the other way I just sort of did it quickly in my head also works. But for those that didn't want to do that, I'll repeat myself. 15 divided by 16 gives me the decimal number, all right? And then I basically took that decimal number I had, I added the 9 to it, so then I had 9 point, and I forget what it was, I think it was 9.375. And then I multiplied that by 14 because there's 14 treads, always one less than the unit rise. So when I multiplied that out, that gives me a total run 139.125. Okay, so then I would see, does this work? Does this give me okay space? If it does, I'm good. If it doesn't, then I can start thinking about, I don't have to have a perfect rise and run necessarily. The building code has parameters for what's the minimum unit run. So you can look at your building code and see, well, what's the minimum unit run? Because then if there's a minimum, you could go to the minimum and that would save a lot of space. Like the smaller your unit run, the more space you're going to save, but it might not make for a very comfortable stairs. It might not be quite as safe the other way. Remember, the building code is a minimum set of standards. It's not the best set of standards. So that's considerations. You could, you know, if you want to cut off, say, 9 inches off of that, then you'd have to look at, well, that would mean I got to cut maybe around 3/4 of an inch off each unit run or whatever that works out to be. And does that still fit the building code minimum amount? And in this case, it certainly would. So those are some ways that you can make adjustments. You got to know what the building code is because you got to know where your flexibility lies, right? So you got to know where your flexibility lies. And there's even some differences when we talk building code, never mind in the US how there's differences. There's differences between the national building code and provinces in Canada as well. So there's a number of these things. So you got to check your local code wherever you are. Okay, so we've got those elements. We've got the risers, 15 risers, 14 unit runs, and we've got that total run. We know that information. Next problem is I want to know how big to make this opening. So I want to know how big to make what we call the stairwell opening. All right, so how big do I have to make my opening to make sure that I have enough headroom? So headroom is, maybe I'll just give myself a little bit more space here, just rub some stuff out, doesn't confuse people. So headroom is a line that's drawn through the edge of the stairs, and then it's vertical. So that's headroom. And so the building code has amounts for what is acceptable for headroom. And in Canada, the National Building Code, it's got for if it's a public space or if it's a residence, right? So one might be a flight of stairs, a fire escape, stairwell in a condominium building, right? That would be the public. It has a little bit more headroom. Inside a house, a little bit less. We're looking at 1,950 inside a residence, 2,050 millimeters if it's in a condominium building. Depends where you are and what it happens to be. That doesn't mean that's all you want. Like you might want more headroom, and so then that would mean if you want to have more headroom, then that might mean that you are going to need to make your stairwell opening bigger. But again, you could run into problems with, well, that's fine, but if I make my stairwell opening bigger, then I make my floor a little bit smaller upstairs, and maybe I got less space, or maybe that compromises where the hallway is and how wide it is. So there's limits to what you can do. Sometimes it's wide open and you can do whatever you want because it's not an issue headroom. So in a lot of cases it is, because space, let's face it, it's at a premium in houses and buildings. But has anybody ever walked in an older house down the basement? I know I've got some dents in my forehead because of it. And I'm not crazy tall, but I am about 6 foot almost. So I do hit my head in those older houses. Well, those older houses were built in the 1920s. I don't know what the headroom requirement was for basements in the 1920s, but I can assure you it wasn't very much, if any, because you have to go by the building code of the 1920s. We've made some strides in that area, because right now it's 1950, as I said. So 1950 is probably about 6'4" or something like that. That's not bad, but if you're Michael Jordan, you're going to hit your head. Or if you're Kawhi Leonard, you're going to hit your head. That's still not perfect, but for most people, it is. It's fine. So they try to work with what's reasonable. To be honest, if you can have more headroom than the minimum, it's good. You know, you got mattresses and different things. It just makes things easier to move up and down the stairs when you're moving as well. There's always, first thing I always look at when I'm moving or helping somebody or doing something like that, how much space do we have? What's the headroom? Trying to figure out ahead of time what you're going to do. Okay, so we've got this issue here, and we know down here we've done our calculation, so I'm going to just rub some of this stuff out because we don't need it anymore. Okay, so I got 15 risers at 7 1/16 and 14 unit runs at 9 15/16. Total run 139.125. So the way that I usually do this, there's a formula in the textbook. I've got a slide with the different, not a slide, but a section that shows the different formulas. You can just plug stuff in. Personally, I like to look at things and just figure it out logically. That way I don't have to commit it to memory. But these days, it doesn't matter that much. You can look everything up anyways. But you want to be able, it's good if you understand it. I think if you're, if you're dealing with estimating, I don't want to hire an estimator that doesn't know how to add and subtract. They're good on a spreadsheet, but they don't know how to add and subtract. I'm a little worried about that. Project manager, I want somebody that understands how the critical path works. They could even calculate it if they had to. They're never going to, because you're going to use the software for sure, but you spot things, you see things, and things don't look quite right to you. But if you kind of intuitively understand it, it's better. It's just better. Same thing with roofs, roof layouts, etc. So it's one of the reasons I like to do this live this way. I thought about it. I could just do it with slides and just talk through the slides, kind of like I did in the previous one, but I don't know. It's not the same. So, at least for me. So I'm going to take the relationships. So what this is really similar triangles. And one more bit of information we need here. So I'm going to say that this is 12 inches. So the thickness of my floor, and that counts my drywall, my subfloor, and my hardwood flooring. So remember I said finished floor. I was really counting to the top of the hardwood, right? So it counts everything. When I say 12 inches, it counts everything. It's not just the height of the floor joists. It's counting the subfloor. It's counting the hardwood. It's counting the drywall on the underside. All right. So I'm going to say it's 12 inches. I don't know. Maybe it's a 2x10 joist and it's got the other stuff on it. 2x10 joist, 9 1/4, 9 1/8, depending on the moisture content. And then you've got the other stuff adding up to the 12 inches. Okay, so what we're going to do is we figured out what our thickness of floor is, counting the finishes, the drywall, and the hardwood, as we just said. And maybe I'll just try and adjust this a little bit. And so what we want to do is we want to solve for x, which is going to be our stairwell opening. And we have this big sort of triangle that I've got here. If you're not seeing it kind of stand out, kind of should now. And we've got this little triangle which represents our step, right? Each one of the steps forms a little triangle. And it gives you a certain slope, which would be based on our unit rise. So we have a 7 1/16 unit rise, right? And our unit run. So each one of those is 7 1/16 going up. And each one's going 9 15/16 along, like we calculated before. So we have that triangle there, and we have this bigger triangle. Now, we need to know, well, what headroom is acceptable for us? What are we after? You could use the building code minimum, or maybe you want to have a little bit more headroom. So let's take 6 foot 8 inches as that little bit more. And we've said that our floor thickness is 12 inches. So that means that this height here is going to be 7 foot 8 inches from here to the top of the floor. So 7 foot 8 inches is going to be 84 inches, 7 foot, 7 times 12, 84 inches, plus 8 inches, right? So 84 plus 8 is 92 inches. So that's where this is going to come from. This overall height here is 92 inches. So that overall height from the top to that imaginary line going through there. A building inspector, all they got to do is put a straight edge against that and measure straight up to see the headroom satisfies building code requirements. So you have 92 inches. All right. So we now know 3 of the 4 sides if we're going to use similar triangles and sort of basic algebra. We're going to put our 7 1/16 and 9 15/16. And if you do the math, 7 1/16 should equal 7.0625. 16th is 0.0625. I just know that. 0.125 is an eighth, and so on. And then 9 15/16. But if you want to find it out, you just divide by 16. It'll give you that number. And then 15/16, it's a little bit more tricky. So that would be 9.9375. And just because I'm doing this live, let's see. You can check yourself as well. It doesn't have to be me entering all this stuff. So if I go 15 divided by 16, that equals 0.9375. So I had my 9 inches, so now I've got this in decimals. So they're both in decimals. So I'm going to put them like this. Numerator 7.0625. Denominator 9.9375. And the way I look at this is a vertical measurement, right? So this is a vertical measurement because it's the riser. And this is a horizontal measurement because that's your unit run. So then I want to know, well, is this a vertical measurement? And I'm going to say, yes, that's a vertical measurement. So that I want to make sure goes on the top, that it matches, because this is the numerator. The vertical in this case is on the top. So I want to put 92 on the top. And then what I want to do is put my x on the bottom. And so now it's just an algebraic equation where I just got to solve for x. So I can cross, if it's been a while from school for algebra, you can just cross multiply these two. And that's going to, maybe I'll get rid of this stuff at the bottom. We know this stuff here. You can always go back if you want to check it. So I'll just try to get this off the whiteboard here. It's not as steady as the one at school, so I'm not as used to that. All right. So 7.0625x equals, and then I got to go 92 times 9.9375 equals 914.25. 914.25. And let me just do that again just to double check. So I've got 92 times 9.9375. So I got 914.25. So then all I've got to do to solve for x, all right, is divide 914.25 by 7.0625, and I do the same thing over here, 7.0625. Okay, and so that's going to be divided by 7.0625. 129.45 inches. So x from here to there is 129.45 inches. So that's my opening, but that would actually be my finished opening. So I have to allow a little bit for my drywall and a little bit for whatever finish I'm putting here. So if I want, I could allow 3/4 and 3/4. That would give me 1.5 inches. So really, I would be making this opening at least 131 inches. So I'd be making at least 131. I'd probably make it about 132. A little bit extra space. I can always build it in, or worst comes to worst, I've got extra headroom. That's all it's going to do for me. It does take a little bit off the floor above. So maybe you're tight, then that's where you can look at that. I'm not working with the exact building code, so I've got a little bit of flexibility there too for an interior residential residence. So I've got a little bit of flexibility. If you're working with just a building code number, you really got to be careful because you don't want to compromise that aspect. As I have mentioned before in different classes, I had a student that he worked for the laborers union, and in a whole condominium building, he had to take a chipping hammer and angle this out here, right? He had to angle that whole section out of the concrete, every floor going up, because they messed up with the precast concrete steps. And then inspector saw that there wasn't enough headroom, and so the only way to rectify that was to do that. Not an easy situation, you could imagine, right? So you want to be sure about your measurements. You want to be sure about what you're doing as far as the layout goes. And there's nothing wrong with allowing a little bit extra. You can always build things in a little bit, not in a lot, but a little bit. And then that's good. So hopefully that's just to give a quick recap, giving you a good idea. We worked with what's the most comfortable unit run and unit rise, the relationship between the two. So if you're going steeper, you want a little bit narrower unit run. And if you're going not as steep, then you want a little bit wider, because one is more like walking and one is more like climbing. So that'll give you a comfortable stairs. And if you've got an unlimited run, you've got a lot of flexibility there. Nobody has truly unlimited run, but you might as well try to make the stairs as comfortable as possible, as it doesn't take any more effort, and you get used to the numbers, and it's easy to do. And so that'll give you that nice sort of flow up. All your risers have to be exactly the same height. And so following that calculation we did earlier, that'll give them all the same height. And to solve for x, we just got to know what's going on. And then it's sort of basic algebra going on. So that's what I wanted to cover today. Hopefully everybody's got a good idea what's going on. And this is Tom Stephenson for now, wishing you a wonderful day, and we'll see you next time. Bye for now.